Introduction to Geometry. So the first test was just what you're going to need from algebra. So some basic unit conversion, rounding, and solving for x. Now we're actually going to start into the geometry stuff. So these notes are the basics for all of geometry. So it's just going to give us a little bit of overview. So the first thing are a few definitions. So a point, line, and a plane. A point is very simply just a place in space. Okay, now this place, and that is a C, this place, it has no width and no length. I'm sorry, my board's a little slow, so I have to write slow. But it has no width or length. But we will put a dot there to show where the point goes. So if I have point A, and you should always know that they're always labeled with a capital letter. Okay, so they're always labeled with capital letters. And you'll see all the letters of the alphabet, A through Z. We can use whatever. But for now, I just use A. So whenever you see a dot there, it's a point. It's just a place in space. But remember, there's no width or length. You couldn't measure to see how many centimeters high or wide it is or anything like that. Now, a line is just a series of points. So if I were to take an infinite number of points, if I were to take point A, B, C, D, E, F, G, and keep going, that's eventually going to make a line. So on that line, there's an infinite number of points. I can put as many points as I want on there. Let's say I put points, that's supposed to be a B, C, and D. But again, there's an infinite number there. I can put as many points on that line as I want. Okay, and it does go on forever in both directions. Now, of course, I can't draw it forever because my board stops. Okay, but even if I could draw through my board to the wall, to the chalkboard, through the walls, whatever, I could keep going. It's still, you have to imagine that it goes on forever. Now, when I named a point, I just used a capital letter. Now, to name a line, you can pick any 2 points. Okay, so I could say that this is line BD, and then I'm going to place a line symbol over top. I could say this is line DC, and place it over top. Okay, you can pick any 2 points to name. What you don't want to do is use 3 or more points. So we're not going to say line BCD like this. We don't want to do that. Okay? We want to use 2 points to name. 2 points to name. And it can be any 2 points in any order. Okay? 2 points to name. Try to fix that W a little bit. That didn't really help too much. But 2 points to name. So, points, lines, and now planes are a series of lines. So, we took an infinite number of points and we lined them up next to each other to get a line. Now we're going to take an infinite number of lines and lay them out to get a plane. So if you think about it, if I would take line, 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 and I keep lining them up like this over and over and over, what am I going to get? Well, I'm going to get a flat surface. So we don't talk about planes too much in this class, but if you think about the floor as being a plane, or the walls, or the ceiling, or the door, or your desktop, any of those would be planes. Okay, so a series of lines, a flat surface. 3 more definitions, I promise. I'm sorry that we have to go through these. I know there's usually not a lot of definitions in algebra, but there are some definitions in geometry. So the next one is a line segment. So we see the word line already in here. So it's kind of like a line, and it's actually a piece of a line with 2 endpoints. So if I take any piece of a line and has 2 endpoints, it's going to look like this, an endpoint here and an endpoint here. So let's name this E and F. Now to name it, you have to name it with those endpoints. So let's say point G is also on there. Okay, but if I'm talking about the whole thing, then I have to name with the endpoints. Name with the endpoints. So I have to name it either EF or FE. That's it. If I were to go back a slide and go back to the lines, I didn't have to use B and D. I could have used anything I wanted, and the order doesn't matter either. So I could do BD or DB. I did DC, I could do CD. Or I could use, let's see, BC. I could use BC or CB. I can use anything I want. Or any of these points in here. Remember, there's an infinite number of points. I could use any 2 points I want. It does not matter. But with the segment, I have to use the endpoints. So EF and FE are my only options. Okay? So array is also a piece of a line. But it's a piece of a line with 1 endpoint. So that means it's going to look like this. 1 endpoint, and then the rest of the line. Remember, lines go on forever. So if I'm going to name this H, and let's just say I'll put I and J on here as well, because remember there's an infinite number of points happening here. Okay, that's what array looks like. So it has 1 endpoint, and then it still goes on forever in one direction. So now when you're naming this, arrays are the toughest ones to name. Okay, you have to start with the endpoint. Okay, so you name with the endpoint first. Oops. Told you my board's acting kind of weird today. So all the time you want to name with the endpoint first. So in this case, H would be first. Then I could use I or J. You can use any other point on there. So I could make it HI or HJ. And then you put your little ray symbol on the top. Okay? Even if it's not pointing in that direction. Let's say you have a ray that's starting here and pointing in this direction. And let's say it's K and L. I'm still going to name it with the endpoint first. So L would be first, then K, and my arrow pointing to the right. So you don't switch up the order to point in the direction that your array is going. It's always endpoint first, then another point, and your ray will always be pointing to the right. Okay? And the last one, collinear. Okay? Collinear just means points on the same line. That's all it means. So if you see that word collinear, that just means points that are on the same line. So E, G, and F up here, those are collinear. They're on the same line. But F and I and H, H, I, F are not collinear because they're not on the same line. So E, G, and F are, H, I, and F are not. So here's some practice. on all of those definitions that we just did. So first it says to name the line. So again, if you're naming a line, that means it's going to go on forever. You can pick any 2 points you want. So there's a ton of different answers here. So let's say TR with a line. That works. Let's say SM with a line. That works. Let's say TS with a line. That works. And RM with a line. That works. Okay? And so on. You can pick any 2 points you want, and the order doesn't matter. Lines are the easiest ones to name. Now, these questions down here are asking, are things the same? Okay? And I'm going to try to color in to show you what they're talking about. So is line MT the same as line TM? Yes, it is. Line MT talks about the entire line, the whole thing. And so does MT, because it goes on forever in both directions. Is TR, so it's a segment now, there's no arrows. So is T to R, is that the same as R to T? Yes, it is. There's no arrows happening. It's just in between those 2 letters. So are they the same? Yes. Now let's look at the next one. Is MS, so now this is array. Remember, the first point is your end point. So is M, starting here, to S, and going on forever, is that the same as my end point starting at S and going here through M? No, it's not. They're not talking about the same points. They are not talking about the same piece of the line. Ray MS starts at M and goes this way forever and ever and ever, whereas Ray SM starts here and goes left forever and ever. So they're not talking about the same thing. Is RT, so again, this is a ray, so I'm starting at R here and going through T, so I'm going this way. Is that the same as RM, ray RM? So again, R, and I'm going through M forever. Are those the same? Yes, they are. They are talking about the same exact thing. They both have an endpoint at R, so they're both starting at R, and they're both going the same direction. So yes, they are. So now, I want you to try the right 4. So pause the video, think about it. If you want to color them in yourself, you can think about it. Okay, but I want you to think about those 4, pause the video, and then in a few seconds the answers will come up. Okay, so there are your answers. No, yes, no, yes. So ST and RT, no, they're not the same. They don't start at the same place. RM and MR, those are lines, so yes, they both go on forever. TS and TR, nope, those are just talking about the endpoints. So between T and S is much bigger than between T and R. And finally, MS and MT, yes, they both start at M and they both go the same direction. So here's some more practice with our definitions. I want you to take a moment and I want you to try these 4. Okay, just giving other names. So pause the video, give it a try. So here are your answers. All of those red answers are acceptable. Anything on line AG, so you have 4 points, A, F, G, C. Any combination of those, of 2 letters will work. Doesn't matter the order, doesn't matter the points, as long as they're on that line, they work. Okay? For Ray BE, you only had 2 options. Remember, you start with the endpoint. So B is the endpoint, and it goes in the direction of E. So it's talking about this, and then this way. That's what it's talking about. So as long as you also started at B and went that direction, so BF or BD would both be the same. For the segment, you only have 1 option. DF and FD. That's it. It's talking about the points between those 2 points. So that's all you can use. And then 3 collinear points, there's a ton of different answers you could use. Any 3 points on the same line. So BFE is what I chose. You could have also chose AGC. A, G, oh my goodness, G, C. Okay, any 3 points, it doesn't matter. So the last thing we're going to do here are 2 sketches. 2 slides of sketches is what I mean. So we're sketching the following. So if I'm going to sketch ray RM, okay, I know R is my endpoint, so make sure you put a point there, and that's R. And now M, so I'm going to draw my ray, and I can put M anywhere along here. I can put it real close to R, I can put it up here, anywhere I want. But again, make sure you put a point to specify where that point is. Don't just write the letter M. So there's my ray, RM. FT is a line, so there's point F, there's point T, and here's my line. Make sure you are including arrows where they need to be. And finally, my segment LP, so again, I'm making 2 points, LP, only now I'm creating a segment. So I'm not going beyond those points, I'm not adding arrows, it's just those right there. So this is the last slide we're going to do together. The bottom 2 slides are just extra practice for you. If you want to see the answers to those, the completed notes are on the classroom. So these directions below, all 6 things we're going to do in one sketch. We are not going to make 6 different sketches. We're going to do one sketch with all 6 steps. So step 1 is to draw 3 points that are not collinear. Remember, collinear means on the same line. So I don't want to do 1, 2, 3 right in a row. I want to make them not on the same line. So 1, 2, 3. Okay, so that was step 1. Step 2, label them A, B, and C. So let's make this A, this one B, and this one C. Okay. Step 3, create segment AB. So between A and B, I'm just going to connect them. No arrows needed. Now, step 4 is create ray BC. So ray BC starts at B and goes through C, and it's going to keep on going. So I include that arrow. Step 5, place a point on ray BC between points B and C. So between B and C, I need to place a point. So here's a point, and then label it point D. There we go. And finally, step 6 is create line DA. So there are my arrows. Okay, so when you are making these sketches, and you will be asked to make a sketch on your test, make sure you're doing it all at one time. Notice that all 6 steps I did together. I didn't make a separate sketch for each step. Okay, so the next slide is another sketch, and then the last slide is another yes, no kind of questions. So again, that's just extra practice for you. If you want to see the answers, look on the completed notes on Google Classroom.